Hi students, today we will discuss the best question from integration, that is, let I1 equals to integration from 0 to x e power tx into e power minus t square dt, and I2 equals to integration from 0 to x e power minus t square by 4 dt, where x greater than 0, then the value of I1 by I2. Now coming to the solution. Now I1 equals to integration of 0 to x, that is e power tx into e power minus t square. So that I can write this one as e power minus t square plus tx dt. Right. So from this, I1 equals to integration of 0 to x e power, if I take minus common, then it is e power minus t square minus of t square minus tx whole dt. Then from this, I1 equals to integration of 0 to x e power minus of this one t square minus 2tx by 2 plus x by 2 whole square minus x by 2 whole square. We can write like this into dt. Now this is I1 equals to integration of 0 to x e power minus of the first term t minus x by 2 whole square, the first three terms like that, minus this one x by 2 whole square whole dt. Now if you multiply with minus, then that exponent 0 to x e power x by 2 whole square into e power minus of t minus x by 2 whole square whole dt. Now anyway the integration with respect to t, that e power x square by 2 x square by 4 is independent of that, so that I can write outside of the integration e power x square by 4. This is what integration of 0 to x e power minus of t minus x by 2 whole square dt. For suppose if t minus x by 2 equals to z, now if we do the differentiation, then dt equals to what will get dz. And coming to the lower boundary, in case of that t equals to 0, then z should be minus x by 2. In case of, for suppose t equals to x, then z equals to x by 2. So now we can write like this, I1 equals to this one e power x square by 4 integration of, the lower boundary should be minus x by 2, upper boundary is plus x by 2, and this should be e power minus z square into dz. This will be the I1. Next. And anyway, if you want to do further simplification of I1, let's see this. Now see this. For suppose e power minus z square, if it is an even function, and it's an even function only, and we have a condition that in case of even function, minus a to a f of x dx equals to 2 times of integration of 0 to a f of x dx. So based on that, I can write I1 equals to e power x square by 4, and that is 2 times of 0 to x by 2 e power minus z square dz. Okay. So this is what I can say that I1. Now coming to I2. What is I2 here is 0 to x e power minus t square by 4. Integration of 0 to x e power minus t square by 4 dt. Now this I2 I can rewrite as 0 to x e power minus of this one I can write as t by 2 whole square dt. Now in this question t by 2 equals to, if I say that z, then dt equals to 2 times of dz. Now coming to the lower boundary, if t equal to 0, z is also equal to 0. If t equals to x, then z equals to x by 2. So these are the boundaries. Correct. Then I2 can be rewritten as integration of 0 to x by 2, right, e power minus z square into this dt 2 into dz. This is what the second condition. Now if you observe the first condition, 2 times of 0 to x square, this one 2 times of 0 to x by 2 e power minus z square dz, and this is also 2 times of 0 to x by 2 integration. This one is nothing but I2, right? So from the first one, I1 is equals to e power x square by 4 into the remaining term completely I can say that it is I2. So I1 by I2 equals to e power x square by 4. Thank you.